Okay, we're recording. Hello, my gentle and modern apes. I'm Erica, and today I'm here with Maddie, and we're going to be discussing a few different things, and we're likely going to be editing it up into a couple of little segments because both of us we do enjoy the science rambling, and I know Maddie is just like me, and that once we get going on our monologue, there's no stopping that train. So you guys, of course, know me, but I'm not sure, you might not have been introduced to Maddie if you haven't had the absolute pleasure of watching her debate Dr. Jeffrey Meldrum on the existence of Bigfoot over on Modern Day Debate. That is 100% something that you need to go do ASAP. It is one of the most fun conversations here on YouTube, in my opinion. So, Maddie, would you like to go ahead and introduce yourself? Tell us about you, what you do, your work,
Sure.
academia, and your channel.
Well, more importantly, this is Chester. He's going to make some appearances. He's a very good boy. So yeah, I'm Maddie. I have a channel here on YouTube, Science Side Up. We talk about science over there. It's super fun. So I have a background mostly in like physical sciences. So I have a bachelor's in math and earth, atmospheric, and planetary sciences from MIT. Then I ran off and joined the Navy. I spent 4 years like teaching nuclear physics for the Navy. And then I went to grad school. So I have a master's degree in meteorology from the University of Oklahoma, and I'm working on my PhD also in meteorology. I do Arctic weather and the connections between the weather and sea ice, and I think it's super fun. I'm sorry, Chester is rolling. He needs his belly rubbed so bad.
He said, I noticed that you're giving attention to someone else.
To someone else, and I'm not here for that.
Yeah, and I'm just, that ain't gonna fly here, Chief.
Mm-mm.
Well, that is impeccably broad. That is such a broad range of expertise. So you've got the math in there. You've got planetary atmospheric science. You've the earth science of our skies essentially, and the chemical composition, how that changes through time and in the present. And then you've got nuclear physics tucked away as well.
Just snuck in there.
Snuck in there, and then general meteorology for a master's, and then now you're specializing further with Arctic climate and weather, and that's just what a broad soup to ladle the knowledge out of.
Yeah, it's just that I don't sit still well.
Yeah, I agree. I can definitely empathize with that.
That's half of why I started a YouTube channel, so I can look, guys, I'm only allowed to talk about Arctic weather all day, every day in school, but I need to randomly talk about Compton scattering and the photoelectric effect.
Nice outlet, right? And
such a good outlet.
I was so pleased to find, hopping here on YouTube, how many giant dorks there are out there who are just as nerdy as I am, who are like, oh, we're discussing the causes of the Triassic mass extinction. I couldn't be more interested. And I'm like, okay, these are my people. I'm here for it.
Absolutely.
What was your favorite? What would you say your favorite of kind of your academic endeavors has been so far? Okay,
this is so nerdy, but I hope we're here for it.
Yeah, I promise.
Okay, I love, there is the subfield of mathematics that is physical applied mathematics. So that is applied math as it works with the physical real world. Applied math is almost like theoretical computer science and math that applies to the real world, and I'm over here.
Exactly.
So the intersection of that field and specifically chaotic dynamics and how that relates to geophysical fluids.
Oh my God.
So I love the math of Earth systems. Turns out the atmosphere is trying to do like Navier-Stokes full fluid dynamics with a compressible fluid on a rotating sphere is it's this insane complexity and beauty. Oh, and turns out it is heated at different angles at different times, right? And does weird things. So I love it for the math specifically.
That's so okay. That's so I so agree with you, but in the opposite direction. Because to me, I find the math intimidating, but I very much found myself enjoying learning about the different cycles of the Earth. So the carbon silicate cycle, for example, is one of the ones that I maybe a year and a half ago knew nothing about. And looking into it, I found it first and foremost very alarming because I was like, okay, it's really interesting. All of these mass extinction pulses have to do with the disruption of the sequestering of carbon from the atmosphere back into the earth. You
And
know,
we have this net carbon sink that's only fixed by volcanism. So I know
right.
volcanoes can absolutely cause mass extinction events when you have those like super volcanoes.
Mhm.
But if we didn't have them, there could be no life.
Right, because we need the weathering to re-get all of that carbon back into the sea for the shells of the arthropods and some of our mollusks and things like that, which blew my mind. That you've got these folks who are reconstructing paleo environments by looking at the ratios of elements in the shells of long extinct creatures, and I was like, they're so clever how they figure this stuff out.
Yeah.
They're like, okay, we can get a clue, or just isotopic ratios just kind of blow me away in general, like how much
Yeah.
they tell us. But I don't think that that's nerdy at all, honestly. I think that that is wholly defensible. So
And I have to say, I actually find biology incredibly intimidating.
really,
Any
we've got
what
to
I refer to as
supplement this
squishy
thing.
science. Um,
Squishy things, yeah.
yes, the science of squishy things. I just get like so intimidated. I don't like it. And it's because what I really like about math is uh, you get analytic solutions to things, and there aren't cases, right?
There's
Like,
a
well,
constancy,
sort of
right?
kind of like this,
Yep, yep, yep.
it's very concrete, and I find that deeply comforting. But like, and even like like I said, I've been like binging some of your young earth creation dunking while I've been coding. It's very entertaining. You're keeping me sane. But like when you can just like rattle off family names, or names of species and things like that. I'm really bad with details. I don't remember details, but I'm good at like remembering the overall picture and how to reason through to the right answer, which is helpful in physical science, right? So
We're a good compliment then, because
yeah.
I'm definitely the opposite. I think like I'm from a biological perspective, right? Any of the biological science, like you said, it'll be like, here's a general observation, except for all the exceptions, and like, oh, okay, like because organisms are just remarkably plastic, and that they will just adapt and evolve to whatever environment that you put them in, supposing that they've got the proper genetic repertoire to pull from. I'm giving them agency, of course. The agency is not really there, in my opinion. But that being said, I'm hoping so on the agenda for today, and my other dog just came in, the one I was calling a little bit ago, and she wouldn't come now. Of course, she's here because she's like, oh, I see that you are also giving attention to someone who is not me. Here's one. Ted.
Here, you can see his handsome bow tie.
Ted, come here.
Oh,
Teddy.
hi, Ted.
Teddy.
Oh.
What are you doing? She's bad.
Hello.
She's a bad one.
Chester's like not making eye contact with me. Hey, bud.
Is he Australian cattle dog or blue ticular? Or
red heeler.
Red heeler. Red heeler.
Yeah. Aren't you?
Look at him. Oh, I love his little. He's got like that kind of brindly coat. Kind of brindly. I don't know what.
I don't know what it's called, but he has spots where it looks almost like a deer.
Yeah,
right?
like a model-y. Yeah.
So he's so handsome. Okay.
Okay. To be fair, I've yet to meet an unhandsome dog.
Right.
All good boys, all good girls.
Right. The dog we had before this guy and his brothers around here somewhere was ancient mutt of mutts. Yeah. Right. Blind in one eye, deaf, couldn't walk in a straight line.
Yeah.
I just thought he was the bestest boy.
The most good.
Good.
Yeah. Even when they're bad. Yeah. Mine are good even when they're bad. And this one, my golden, she's horrible about eating socks, and so she ate another sock the other day.
Honey, that's not food.
No, it's not. And the thing is that I'm very particular about like, okay, she needs no access. So it's been several months since she's gotten access to a sock, but I was doing laundry, and I guess I was carrying the laundry basket and one fell out. And so she was having a real bad time in the backyard the other day. I was like, okay, well, is this going to be a vet trip, or is it going to make its way through? Unfortunately, it did make its way through, but a bad dog who is a good dog.
Yeah.
So today on the agenda, speaking of passing socks, today on the agenda, we're going to talk about a couple of things. I'm interested in picking Maddie's brain with regard to specifically Miocene climate change, because that in kind of the area that I'm very interested in is paleo-environmentally speaking, what pressures led to first the diversification of the apes, but then finally the kind of pressure and advent of bipedality sort of in Africa. So we're going to kind of dig into that a little bit. And then, because it wouldn't be a stream if we didn't, we are absolutely going to engage in some hardcore dunking on young Earth creationism, which is going to be very fun because Maddie has a channel, which you'll find the link in the description, and has published her first dunking on creationism video, young Earth creationism video. So you're going to want to check that out. And we're going to be, I believe the plan is, we're going to discuss in the context of some cosmology, as well as just any other area that we kind of feel like getting into, because I don't do a lot of cosmology on this channel. And I think that it's going to be an absolute ball to get a different perspective, because boy howdy, as you've heard it said on this channel before, young Earth creationism is precluded by every branch of every science. So it's always nice to get into areas that maybe we're not as familiar with. So okay, let's kick it off. Tell me about the climate of the Miocene, and inform everyone of the climate of the Miocene, if you would like.
Excellent. Sorry, I am trying to pull up a very good figure that, oh, I emailed it to you. That's how I can find it quickly.
Yeah, I know the one you're talking about. I'll put it up, flash it up when we're talking about it so everyone can appreciate the.
Okay, perfect. I'll stop digging through my email then. Excellent.
Yeah, don't worry about it. That's the joy of editing.
Excellent. Okay, so one, let's talk a little bit about how we know things about paleoclimate, because I think this is very fun. Because I think it's always a really good question of how do we know that? That's always a question we should remember to ask. And so, okay, so let's think about like what we can know about past climates. One of the things we can know is we can know the temperature in a globally averaged sense. And so that's a very climate type of thing, not a weather kind of question. So, a climate increase of 1 degree Celsius is a huge deal, even though our weather, the weather here in Oklahoma swung 80 degrees in the last week. But that's, so that climate versus weather, I think if you don't think about this stuff every day, that can be difficult to remember. So from a climate global average sense, a degree or two is a very big difference.
Would it be fair to say that climate will necessarily, of course, impact weather, but weather isn't necessarily at any given time a good picture of climate?
Exactly. So climate, yeah, that's a really great way of putting it. Another way to think about it might be that like you and I should not experience a change in climate in our lifetime.
Should.
Right.
That's a very, that word's pulling a lot of weight.
Should is an important word there. So climate, when it changes, is solely because of natural things and not catastrophes. We can mention that later. But change occurs over, there's natural like decadal cycles. So like, or even like El Nino, La Nina, right? That has like a 5-year period, but that leads to like, oh, hey, it's drier this year and wetter this year. Or we might have 10 years where it's on average colder. So we have, think of things like that. So like, today's weather has, isn't a picture of today's climate. I don't know. Yeah. So things we can know about, so the way that we know about the average temperature through the past is going to be primarily through ice cores. So the amount of oxygen 18, which is a naturally occurring isotope of oxygen, the amount of oxygen 18 that is in the ocean, so oxygen 18 relative like oxygen 16,
right,
is a function of temperature. And so this is where I said I don't remember details well. I think it's if there's more oxygen 18, it's warmer, but I could have that upside down.
Right. I think you're right. I think you're right about that. But while you're talking, I'll double check.
So we can go to places in Antarctica and other places where we have ice that's been there for thousands to millions of years, and dig down real deep and look at the layers of water. And so in that water, how much of the oxygen is 18 versus 16 tells us, we can from that infer the average temperature with, some degree of certainty. So that's the thing that we can know.
So out of curiosity,
Mhm.
how would you gauge the climate during a time period, or the global temperature average during a time period when we don't have any sea ice, like say the Triassic?
Okay, yeah. So the Triassic, um, so there's other things we have. So you don't need sea ice. You actually, because sea ice changes quicker. You want glaciers. So you want that very old ice. And I don't know off the top of my head how old that goes, but if whenever you pull up that figure, you'll see when the data gets really sparse, right? The line gets a lot jumpier, right? Instead
Right.
of like this, it gets boop boop boop. And so you do see the further back in time, the less accurate. So let's see.
I just double checked, by the way, and it looks like, according to uh, University of Oregon, the more oxygen 18 that you have in sediment, the colder the climate, which is
Okay.
inverse to the relationship of glacier ice. So you were 100% correct. So
Okay.
with ice cores, the more oxygen 18 that you have, the warmer the climate is going to be. But in sediment, it's the reverse, which makes sense because of the relationship between sediment and glaciers.
Right.
Yes? Perfect.
Yes. That makes sense. So I am most familiar with temperature tracking through ice cores.
Right.
So I don't have a good answer off the top of my head.
Well, I
My
would
my
imagine it would be sediment, right? Because that's what Adam
Yeah.
said, right? So it would probably be, and I don't know, you would know this more than me, but it would be like, if you've got sea ice available, the glacier ratio is probably going to be almost more reliable than the sediment, because sediment, I would imagine, can
Mhm.
be altered more easily. There can be more
Right.
intrusions, there can be more contamination risk, things like that.
Yeah, because it's kind of like once the ice freezes, it freezes and it's there,
Right.
right? And it just stays there.
Okay.
Um, so the other thing I was going to bring was, we were talking about this a little bit before we started recording, but one of the other things that you can do is go look at shells, anything that's made out of calcium carbonate, because that carbon that's in those shells tells you about how much CO2 is in the atmosphere and even how much methane is in the atmosphere. So carbon dioxide, carbon monoxide, and methane are going to be some of the main greenhouse gases that we track. So if you look at the Miocene period, which is what you were interested in, on average, now how long is the Miocene? That's like a very long period of time, right? It's like a million years.
I think it's
Lots more.
yeah, I think it's quite a bit longer than that.
Sorry.
I don't know. I don't want
I
to get
don't
it
think
wrong
in
either.
geologic timescales very often
No,
these days. I'm
no,
like,
listen, I didn't want to get it wrong either, because I tend to look at it in the sense of how organisms are evolving and changing. So I tend to be
gotcha.
like, oh, it's roughly, in the case of general geologic periods, like on the scale of like 30 to 40, but I want to make sure I get the exact. So the
Okay.
Miocene extends from, it's the first geological epoch of the Neogene, and extends from 23 million years ago to about 5 million years ago.
Okay.
So
So we're looking at about 20 million years.
right, yes. So it's
Okay.
relatively short compared to some of our other kind of
Hmm.
larger periods of time, right? Like the Jurassic is quite long,
Yeah.
the Miocene, but, and you would probably know this better than me, it almost seems like the more recent periods tend to be a lot more truncated when
Hmm.
compared to, like, oh, the Mesozoic has three. And then like, but
Yeah. I think that's just like, if the more data you have about something, the like more categories you can come up with, or like the more differences you're going to have. So when you're in like data sparse, um,
true, that's a great point.
it's really hard. That's kind of like I was talking about, if you on that graph of temperature, when you go really far back, your data gets the frequency of data gets much more sparse.
Right.
So if you look throughout the Miocene, what you're seeing is it slowly cools. It's cooling over that like 20 million year period. But on average, it's about 10 degrees Celsius warmer during the Miocene than it is now. So that is super noticeable, right? That's going to be a big deal. So you're also seeing there's significantly higher concentrations of carbon dioxide and methane, and those are slowly decreasing over that time period.
So that totally checks out. As those of you who may watch the channel know, the Miocene is well known for its ape diversity, particularly in northern and central Africa and extending up into Europe, which is fascinating. It's very cool to think about this idea that, you know, we've got all these wide varieties of apes doing all sorts of different things and exploiting different niches. Niches. I actually got roasted for pronouncing it the wrong way in my last video, but I've heard it both ways, so I always alter it so that everyone is happy. But it's quite funny because today, comparatively, we have an enormous variety of monkeys in comparison to our apes, with which we have relatively few. But Europe was, if memory serves, quite warm, and not necessarily tropical, but certainly not necessarily temperate.
Right. So
Almost
tropical would be the wrong thing, because when you say tropical,
Okay.
from a weather perspective, that's going to imply lots and lots and lots of rain.
Okay. Okay.
So Europe was significantly warmer and very specifically more arid. So what would it's going to be very dry. So I think plant life would have been like, think like grasslands, but those like arid grasslands, as opposed to like a jungle.
Right.
Right. Because to get a jungle, you need lots and lots and lots of rain. So probably, I'm going to kind of speak very generally about atmospheric circulation for a second.
Yeah, please.
So equator, real warm, right? Real warm. So you get warm, moist air, because also around the equator, lots of ocean, right? Lots of water is available. And so you have warm, moist air at the equator, and specifically because Earth is a sphere, very complicated science.
Yeah.
The equator gets more direct sunlight than the poles or further poleward latitudes. So we have a built-in discrepancy, right? It is always there. The equator gets more energy than the poles do. So therefore the equator is very warm. So we have this warm, moist air. Warm, moist air is going to rise, and it's going to try to move towards the poles. It's trying to, nature doesn't like temperature gradients, doesn't like it, wants to mix it, right? So that temperature difference drives literally all of our weather. The atmosphere's job, it's a machine whose job it is to mix, move heat from the equator to the poles. So we get warm, moist air that rises. So right at the equator, you get tropical jungles. You get lots and lots and lots of rain. And that would be enhanced with a warmer climate. So think of those tropical regions, more tropical.
Right.
As that air rises and it starts to move poleward, it's going to cool. And because the Earth rotates,
how can you do that if it's flat? How's the Earth? Yeah, flat earthers don't at us, okay?
Okay, yeah, don't at me, man.
Yeah.
Because the Earth rotates, you have conservation of angular momentum. So the air, if you're standing at the equator, you are moving faster than a person standing here in Oklahoma, because the Earth, we rotate and we get to the same longitude, we get to the same place at the same time, right? So if you move air from the equator and you bring it polewards, it's moving faster than the air around it. So that poleward motion breaks down and you start to get the upper level jet. That's how you get the jet stream. So this rising, moving poleward, and then we start to sink when that cell breaks down at about 30 degrees north. So sorry, this is all to get to why we have deserts where we do.
Right. No, please. I think it's super interesting. I actually have
Okay.
a question, but I want to ask it kind of once
Yeah.
we're
So we have rising air and then it sinks right at like 30 degrees. So that's where the Sahara is, by the way.
Yeah.
So we have a desert where the Sahara is because we have this global circulation of constantly sinking air. So you have very high pressure there. This process is called the Hadley cell or Hadley circulation. Warmer temperatures just makes that whole cell stronger. So if it's stronger, it can move further north. I don't know if that's, you might be getting effects from the feral cell with Europe, but with Southern Europe, you might be getting Hadley cell pushing forward.
Hey.
And 10 degrees Celsius from a climate sense is huge. It's really, really warm. So that's going to very dramatically change things. But we're definitely getting that like strong Hadley cell. And so desert regions that we see now would have been more desert-like and bigger, right? And extending further north. So that's a very kind of baseline understanding of some of this stuff. So what was your question? And then I have some thoughts on natural climate cycles that would have occurred throughout this time period.
Right. So what I wanted to ask though is, given kind of the implications of this area of the equator versus how air is kind of getting distributed poleward.
Yeah.
Would it be a fair thing to say that when climate is changing, it's going to occur faster and more drastically at the equator as opposed to the poles, or would it be inverted?
Yes.
Yeah.
So,
okay.
So it depends. So that starts getting at things called climate feedbacks. So right now, our poles are warming twice as fast as the rest of the planet. This is known as Arctic amplification. This is due to the ice albedo effect. So albedo is just how shiny an object is.
Right.
How much sunlight does it reflect back to space? Ice, very, very shiny. So globally, our albedo is about 0.3, which means only 70% of sunlight that makes it to Earth, like makes it to the Earth's atmosphere, actually gets onto Earth. Doesn't just get reflected like a mirror back out to space.
Sticks around.
Right. But at the pole, the albedo is about more like 0.6 or 0.7. So that means only 30 to 40% of incoming solar radiation actually hits the poles.
And wow.
But as the planet warms, that ice is melting. So now more sunlight comes in and decreasing the albedo, causing warmth, causing more ice to melt. So it's a positive climate feedback loop.
Right.
But if you're in a time period that doesn't have permanent ice sheets, then the ice albedo effect wouldn't be in play, and you would still have enhanced tropical warming because of water vapor feedback. So you did get different feedbacks at different places along the planet.
So it depends on the starting point, right? Like
it does.
Would be empirically very different in the Triassic, as we were discussing, where there's no ice at the poles, versus now where we've got tons of it at the poles, less and less every year. But how that's going to, which direction we're going to be going in, how fast we're going there, and which areas are speeding up faster than others.
Yep. So just randomly, I'm gonna plug. Those are all things I'm doing a climate dynamics series. So for you don't have to know anything about weather or climate or math for this. It's kind of trying to teach it at a very colloquial level. So come check it out. We have fun here. We're about to get into climate feedbacks.
Oh man. Okay. Again, link in the description.
Thanks, team. So I did actually want to bring up other natural climate cycles. So these are called, have you ever heard of Milankovitch cycles?
Yeah. Yes.
Excellent.
Well, is the Milankovitch cycle, I feel like I've heard this before. Is it not partially responsible for the cycling that the Sahara goes through from tropical to desert, like desertification, and then regaining its tropical nature?
It should be, yeah. So there's three aspects to the Milankovitch cycles, but they all have to do with Earth's orbit.
Okay.
So one is the eccentricity of Earth's orbit. So how we get very close to a perfect circle, and then we get less close to a perfect circle.
Circle oval, right? Like back and
Yep,
forth.
yep. More of an oval. And that we switch from one extreme to the other with a period of 100,000 years.
Okay.
The next is obliquity. So that is Earth we're not rotating straight up and down, we're at a tilt. And we tilt between, it's 22 or 22.5 degrees up to like 24. I could be getting that wrong, but it's no more than a 5-degree swing. It's actually very small.
Right? 23, give or take 0.5, something like that.
Well, right now we're at 23.5.
Okay.
But we get down to like 22 or 22.5 and up
Wobble,
to like,
right?
So we wobble like that.
Right. Okay, with you.
So, and that happens with a period of 40,000 years. And then the other thing we do is precession. So we're at an angle and this angle kind of wobbles around like this.
Okay.
And that changes with 20,000 years. So you think about those very long period processes, but if you're talking about a period of 20 million years, all of these things are going on.
Right.
And sometimes so one of the biggest things that you will see is the biggest weather climate difference is how extreme is summer and winter. And so how bad are your winters and how much different is winter from summer is sort of what these things feed into.
Right.
So if we're more tilted towards the sun and we have a really high eccentricity, then, well, actually those are going to be competing effects. Never mind. That was a bad example. Let's just go for more tilted to the sun. Then our summers are going to get warmer and our winters are going to get colder.
Okay.
If we have a higher eccentricity, then both at we're furthest away from the sun in January and in July. So that would make summer and winter like colder. Everything is colder. So those are
a favoring of global temperateness versus high seasonality is what we're looking at.
Yeah, absolutely. And when we have high eccentricity, that's also when we tend to see glaciation periods.
Okay.
So I'm pretty sure there were like periodic ice. So we see periodic ice ages throughout Earth's paleoclimate history with about 100,000 years related to that eccentricity of Earth's orbit. So I'm pretty darn sure that there were, even though it was so much warmer in the Miocene, we still had periods of glaciation.
Right.
I don't think it would have been like you wouldn't get the extreme like of our last ice age, right? Because we were way colder. There's like a 12-degree temperature difference.
Everything woolly.
Yeah.
Woolly.
But yeah, everything's so woolly.
It's all woolly.
But even in the Miocene, you do have these climate cycles of periods of glaciations, periods of not glaciation, even with those higher temperatures.
So as an important note here too, for folks on the biology side of things, this is one of the ultimate drivers of evolution and diversity of life. Biodiversity necessarily responds to the environment, and the fact that we live on a rock flying through space that is subject to so much constant change, but change that is it's a predictable change, allows us to almost peer back in time and apply that known rate of change to the organisms that we see and understand a bit more about how each individual is adapting to its environment. This being kind of why I was curious about the Miocene, because this is what's setting the stage for human evolution, bipedality, standing up and peering over these grasses and sedges as they expand out across the Serengeti. And also when the Eastern African Rift is forming, essentially, the Rift Valley. So it's always fascinating to me too, that paleoclimates are that we can know so much about a given environment just by looking at the geochemistry of it all.
Yeah, absolutely. And I don't know if anybody's doing this, but they totally should be using climate models. Most like big computer model climate models are completely open source, right? I love my weather people. They're just all software's free. It's great.
Yeah, I wish we had that on the bio side. It's all paywalls all the time.
Well, actually, this is a very interesting thing with weather. It's part of kind of meteorology is a young field. We've only been around about 100 years. and we're very, very, very take guidance from the UN.
Oh, yeah, I can imagine.
And so we have like a global agreement that we will share weather data because people's lives depend on it.
Yeah.
Um, so I very much like that about my field. It's a very non-proprietary, as anything that has to do with people's lives should be.
Yeah. Yeah. Yeah.
But anyway, what I was going to say is you should. I don't know if anyone is doing this, but if they're not, they should grab these climate models, run them with Miocene data. The only thing you have to do would be change your static land file because some of the geography would be different.
Right.
That would be super cool. Someone get on that.
Yeah. Hey, people out there looking for a thesis project. There you go. It's right
there. You go.
There.
You're welcome.
As if there weren't enough gaps in our knowledge base. There's one for you. Well, that is awesome. I want to do a slight pivot here almost, because I was thinking about something while we were talking, and I'm sure you mentioned that you were kind of checking out, like seeing the channel and kind of what's been done here. And I've been doing the series called Bite-Sized Busts, which is like this idea that in any given field, you tend to stumble across little things that preclude young Earth creationism, right? Like just the minutia of something, and it can be very small, like something like that the diversity of macaques, for instance. This is something that primate phylogeny is very difficult to get all the different varieties of primates that we have today from a progenitor to Stracopithecids, right? So it would be very difficult, and that's something that that makes creationism from a young Earth standpoint essentially impossible. Or like plankton or limestone. How does limestone accumulate? I'm doing one next week on Dinosaur National Monument. I'm just doing a case study on the Morrison Formation and this entire thing. But paleo environments, I think, is such a great example of this, because essentially what you've laid out for us here is we can create this gradient of change based off of known facts of the Earth's orbit and how it impacts regions on our planet. And they leave very telltale signatures in our environments and in the rocks and in the ice. And I imagine that's going to be quite difficult to get if you've got the perspective that the entire geologic column was laid down in a half-year period.
Do you know? Okay, one of my favorite fun. This is a fun geology fact. This isn't even a weather fact. Okay, and this is actually why GPS is the greatest technology of all time, right? Well, if you study global things, GPS is very useful.
I can imagine.
Yeah, so there are places like in North America, right, where you have these big old canyons that were carved out by glaciers moving, and then the glacier sat there for a very long time. It sat there so long that the rock underneath it bent, right? It bowed under the weight. The glacier that was there has long since melted, right? Like tens of thousands of years ago, it melted, but the rock stayed put. And you can measure with GPS the rate that it's bouncing back. Because you could put a little GPS tracker and you can see, oh, we're moving a millimeter a year, right? So like I don't even know how, if younger, like what branch of young Earth creationism would accept that was carved out by a glacier, right? That feature. But like, you'd have to explain like, okay, then what's going on with this? The explanation of this was carved out by a glacier during like the last ice age, right? Which we can date by these ice cores, and we also understand why it would have happened based off of orbital mechanics with very long periods.
Because glaciers take a long time to form, they take a long time to melt, and the rock takes a long time to bow and a long time to elast back to normal.
Right. And so the rates we measure with the rock bowing back to normal match up with all of these things together. It's
a corroboration game. All of Age of the Earth stuff is. And boy, there's I would argue hundreds of millions of data sets that all corroborate across space and time and signal to us not just, okay, the Earth is very old. This is not controversial in science. This is like,
no, it's not.
In the niche areas of YouTube, it's fun to discuss,
Mhm.
But this is nothing that is even on anyone's radar in any field that is in conventional science. No one even knows that these conversations are still happening. That's
Right.
how irrelevant young Earth creationism is. But
Yeah.
it's still like flat Earth. It's still really fun to talk about. But yeah, not only do we know that the Earth is very old, but we have these data sets that cross corroborate the minutia of
Mhm.
100,000 year periods of this time scale, which blows my mind because we can,
Mhm.
as you've said, build up the reality of what it was like living in this time period for organisms at the time. What
Mhm.
challenges did they face? What food sources did they have access to? What did their landscape look like? Which
Yeah.
is so cool.
And another great thing, if we're thinking about like things that are a problem for young Earth creationism land, um, we can see right now the devastating effects on ecology
Mhm.
of climate change, of rapid climate change. So if you want to say that, oh, sure, there was an ice age, but it was 6,000 years ago or whatever,
Mhm.
like, okay, explain to me how anything is alive,
Yeah.
right?
Well, at this one, you'll probably get a kick out of this, but the vast majority of young Earth creationists propose that after the Noachian flood,
Hmm.
that's when there was an ice age. And there was only one, not multiple, but that there was only one ice age, which of course begs the question, why do we have ice age signatures throughout the geologic column?
Hmm.
But I've always think that it's funny to bring up this idea that we have so many Siberian mammoth remains and Proboscidean remains in general. And these guys have long generation times. So you're
Hmm.
giving them a very short time period to go from two elephants walking off a giant wooden boat in the Middle East to
Yeah.
having thousands upon thousands of northern living, cold adapted mammoths and mastodons. So it's a
Yeah.
fun game to play, but
I if I'm going to be completely honest, if a young Earth creationist told me like I understand what the evidence says, and I don't believe it because my like faith requires me to be a mythic literalist of the Bible, right? Whatever like, and so like I know that the evidence doesn't point to what I believe, but I believe what I believe, and everything else just has to have been a miracle or
right.
magic, right? I actually find that a much more honest position,
I'm
right?
totally with you. I've
Like,
said this before to creationists who I've interacted with in like streams and stuff, but it's like,
mhm,
I'm with you. If you want to say it's miracles, that's fine. It's when you
right,
say that the science supports it that it's like, okay, well, now you're in my area and we have to
right,
have a conversation, you know?
right.
So,
Yeah. So that's where it becomes it doesn't become a problem when it's like a belief. It becomes
yeah,
a problem when it's trying to be like, no, but science has to support it.
right.
No, science doesn't have to do anything. That's the point of science, right? The science is as best as we flawed apes here can be. It's supposed to be objective and unbiased, and the beautiful, long, arduous process of all of us becoming less wrong together.
Right. And it's the beauty of looking at a data set and saying, what's it going to tell me? Not saying, this is what I want it to be. Let me
Hmm.
impose that upon this data set. And in our pre-show, you were discussing how applicable your work is on studying how the sea ice forms and like it comes in this cyclical fashion each and every year.
Hmm.
And that is based in our understanding of how these principles of our planet work, these principles that are then applied to the past that then
Right,
make accurate predictions about the present. So
right.
it's quite strange to me that and my example is always with the fossil fuel industry, that we use radiometric dating in the form of basin modeling to say,
Hmm.
where are we going to find the oil? Because you're going to want to look in rich deposit areas of the Carboniferous if you're looking for coal or something like that, areas that
Yeah,
are conducive to the formation of these minerals or
right.
natural resources, I should say.
Okay, so I guess I have to rephrase my position earlier. If you're going to be like, I know that's what the science says, but I just don't accept it because of belief, and then you choose to be Amish, that is the most honest position.
There you go.
That's the most honest position you can hold because you're saying, I can't trust it,
Right.
right? I can't trust it. It can't be real because of my beliefs. So I'm going to not engage with modern science, right? So therefore, That's the most honest position.
Hey, that's true, because the funny thing, it's funny that you should say that. It's like, you know, these folks utilize vaccines that are founded on the principles of natural selection and resistance, and
they drive a car. Because if you are gonna be so willfully ignorant to, like, the thing that drives me nuts with young earth creationism is how they like to quote the second law of thermodynamics a whole lot, and they're real bad at it.
Mm-hmm.
And they don't understand it. And that's like the second law of thermodynamics is all about the work done by engines, right? So if you're like, nope, that's not a real thing, and then go and drive a car, like, that's nope.
Yeah. Yeah,
there's some cognitive dissonance going on.
Yeah, there's some cognitive dissonance, and some, in the case of some folks, some of the more professional young earth creationists who I would argue know better, there's some hypocrisy going on, right? I mean, you've got, I don't know how familiar you are with some of the head honchos, some of the alpha chads of the creationist world, but Andrew Snelling is a geologist from Australia. He works for Answers in Genesis, and he's a big geologist. Yeah, I know, it makes my mouth taste like battery acid, but he's very
Erica, that's how we could make the big bucks. Let's just switch sides.
I'm telling you, that's where the money is. It's completely
where the money is. I get paid so much more.
It's just sell out to the young earth creationists, especially because, you know, one of us walks in there, you come in with the paleo environments, you say, oh, it's totally, no, it looks like a flood. I don't know, looks like a global flood to me. And I come in
like such an easy job.
So easy. And the thing is you can just get up there and talk about stuff you don't know shit about, because they cart Georgia Purdom out there, she's a geneticist. She gets up there and starts talking about geology all the time. So
does Shannon Q call her PhD giggles?
I think that is what she calls her. Yeah, Shannon's great.
We'll only refer to her, Georgia Purdom, the PhD giggles from now on. Ham and Egg News is like one of my favorite YouTube shows. Ham
and Egg News is fantastic. And Georgia is, she's big on the jokes. She gets up there and she gets the crowd rolling. She's a real comedian.
She has such tired mom energy, though.
She does. I know. She looks exhausted. But so
if I worked for Ken Ham, I'm pretty sure. If I worked solely with that, like, okay, so I definitely. So I'm from born and raised Oklahoma, the buckle of the Bible Belt. Definitely was raised what I like to refer to as cult adjacent.
Oh, beautiful.
Yeah. And I know that guy who is every guy on stage with PhD giggles, right? If there's a woman in the room, he's not going to lift a finger to do anything. He gets to be served, right? Her job is to, like, tell him how smart and cool he is, and definitely never contradict him.
Well, and the thing is, she's got credentials that blast most of these guys out of their seats.
That's the thing. She's the most qualified person in the room, and like just has the energy of like tired mom energy, or it's like she is somebody with a PhD in genetics who is being required to run a preschool.
Yeah.
Right.
Yeah. Oh yeah.
Like I have a soft spot in my heart for Georgia Perkin for PhD giggles.
There you
because of the, like,
what she puts up with, probably
what she puts up with, and the just deep misogyny that is there, and probably that she's internalized some. Like, that's not, I don't need to like comment on that.
There's a lot of culture going on there. There's a lot of social
pressure
yeah
there. And so I feel for her in a way that I have sympathy and empathy for her in ways I don't for Ken Ham and Bodhi.
You're so right. And like, we have Bodhi. We some of my buddies have talked about too, you know, it's like it really is a big ol' for lack of a better term, like, it is a big old sausage fest over on Young Earth Creationism. There are very few women in it, and that's because I imagine most of them don't have the patience, because they'll find a Young Earth Creationist PhD, however rare they are, who happens to be a woman. And she probably comes on there and realizes that she's not going to have a bogus position and also get treated like shit by people who are objectively less qualified than she is. I mean,
Yeah.
I can totally see that being the case. It's
Yeah.
real interesting.
Yeah, and the main reason I was raised cult adjacent was because like the like look, my mother used to give my sister and I little algebra problems to keep us quiet in church, right?
Very
Like this
good.
was right. Oh, but my parents very intentionally they didn't want to raise us in a church where women weren't allowed to have leadership roles,
Yeah.
right? And so that's very, very prevalent around where I'm from, very prevalent. I even went to I went to high school at a very small evangelical Christian high school, which was not, I got a very good education there. It wasn't like AIG curriculum, you know
Right.
what I mean?
Right.
So it's like, but I feel like I've got like a foot, I had like a foot or the people that I went to school with, like they're,
Toe dip.
yeah, it was a little toe dip in the cult, right? So close enough that my like cult-o-meter is really finely tuned.
Yeah, I'm totally with you, because when I see young Earth creationism in the wild, my fight or flight reflex, and I'm like, oh, here we go. I'm
Right.
ready. I'm ready. But
Yeah.
I went to a young Earth creationist middle school, and
Ooh.
they had a whole curriculum in Bible class, which was one of the classes.
Mhm.
And I always resented the idea that once we got to like sixth grade, we lost recess, but we kept Bible class, and I was kind of like, hmm. But they had a whole worldviews course where they were like disparaging any other worldview that wasn't this particular interpretation of
Yeah.
the Bible. And I remember after I left that, I realized, and as I've kind of moved through my education, it's just like the vast majority of Christians and religious people in general here in the West are
Mhm.
totally chill. Like most of
Yeah.
them are just like they're doing their thing, they have their opinions, but they don't let it get in the way of their work, of their science.
Yeah. A
Um,
fact I like to bring out is I think it's 60% of scientists
mhm.
worldwide practice a faith of some sort.
Yeah, yeah,
Right.
and it coincidentally or incidentally rather, at least in biology, but I believe it spreads across most of STEM. It's something like 98, 99% are wholly accepting of evolutionary theory and of course the age of the earth and things like that.
Right.
And it's because there's massive application to
Yeah.
both of these facts of our reality. And they can have
It,
their faith is totally fine with it. Of
right.
course it is, because
And you also find that the majority of people of faith have no problem with with age of the earth.
conventional
Sorry,
science, yeah.
I almost said that wrong.
Yeah.
I said that wrong and I panicked mid-sentence.
Yeah, it's like conventional science. I'm with you totally.
Right, yeah. So it's really this incredibly niche
Yeah,
group.
it
It's
is.
incredibly niche. It's incredibly fringe. Um, and it is, and I think it is, if not dangerous, then certainly damaging to its own members,
Yes.
right?
Yeah.
And so that's, um, I've got some empathy there, um, uh,
And these
for people kind of trapped in that, or who genuinely believe that, like, so for a woman like PhD Giggles, who genuinely believes that, like, I can't be an authority over a guy, even though I'm objectively more qualified, even
Yeah.
though I'm objectively better at this, even though he's an ass.
Mhm.
But my faith requires this of me. And that's like, that doesn't make me feel anything but like empathy. And honestly, it makes me feel sad. Right.
I wholeheartedly agree. And from that perspective too, the youngsters and as you mentioned just then, specifically young girls,
Hmm.
who see to themselves, who think to themselves, yes, I would love to be a great scientist someday, and then they're faced once they get to a higher education, because of what they were brought up believing that they must choose between
Yeah.
science or their faith. And because their faith is intrinsically tied to their community, it's
Hmm.
everything, you know?
It's, you have to choose, you're choosing between your family, you're choosing between your friends, your entire support network is tied up in that.
And how many
Um,
great scientists have we missed out on,
right.
because of stuff like that? And that
Yeah.
sucks so much.
Yeah.